Welcome to another Win with Math video. Today's video, given that the polynomial f of x is divisible by x minus 4 and all the zeros of f of x are integers, solve for n. So we're given that x minus 4 is a divisor, meaning that x minus 4 is equal to 0, or x equals 4. This means that f of 4 should equal to 0. Now, we'll take that x equals 4 and we'll substitute into f of x, and we'll get this, which will simplify. 4 cubed minus 4 squared is 64 minus 16. We'll distribute the negative and the 4 to get negative 4n squared minus 4n. And then we have the rest. And then we'll combine like terms to get 0 equals 50 minus 2n squared. Add 2n squared to both sides. Then divide both sides by 2. Then take the square root. We have n equals plus or minus 5. So we have two possible values for n. We just now need to check to make sure which ends, or both ends, will have all the zeros of f of x to be integers. Now that we know n is equal to plus or minus 5, we'll test n equals 5. So we'll substitute into f of x, and this is what we're going to get. We'll simplify it. We get x cubed minus x squared, and then we have negative 30x plus 50 plus 20 plus 2. And then we'll combine like terms to get x cubed minus x squared minus 30x plus 72. Since we know x minus 4 is the divisor, we're going to factor out x minus 4, and we need to find the other factor. So we'll use synthetic. So we have x minus 4 equals 0, or x equals 4. The coefficients of this cubic will be 1, negative 30, positive 72. We'll draw our lines, and then let's use our synthetic. So we're going to add straight down to get 1, multiply by x equals 4 to get 4, add straight down, then multiply by x equals 4, add straight down, multiply by x equals 4, and add straight down, and we should get 0 as our remainder. As for the 1, 3, negative 18, that means that we will have the factors 1x squared plus 3x minus 18. And that can be factored down to x plus 6 and x minus 3. Now we use the zero product property to get each of these equal to 0, and solve each of them. We get x equals 4, x equals negative 6, and x equals positive 3. And we want to check to make sure that all the zeros of f of x are integers, and indeed these are all integers. Therefore, n is equal to positive 5 as one of our solutions. Now we need to test that if n is equal to negative 5, will this give us integer solutions? So we'll substitute n equals negative 5 into f of x. We'll simplify, we get x cubed minus x squared minus 20x plus 50 minus 20 plus 2. Simplify some more, we get x cubed minus x squared minus 20x plus 32. Since we already know that x minus 4 is a factor, let's use synthetic. So we'll set it up. So our cubic this time will have the coefficients of 1, negative 20, and positive 32. Draw our lines, and then we're going to add, multiply, add, multiply, add, multiply, and add. And we should have a remainder of 0. So 138 means we have 1x squared plus 3x plus 8. We'll use the zero product property, and we'll see x squared plus 3x plus 8 equals 0 does not give us integer solutions. And to verify this, let's look at our discriminant, b squared minus 4ac, where b is 3, a is 1, and c is 8. Simplify this, we get negative 23, which is less than 0, meaning that this should have two imaginary solutions. Therefore, n equals negative 5 does not provide integer 0, so we can eliminate this and cross it out. Therefore, n equals positive 5 is the only solution where the zeros of f of x are integers. If this video helped, give it a like, subscribe for more, click on the video on screen to keep learning. Thank you.